Hello students, by this video let us study about the balancing redox reaction by ion electron method. So by the last videos we have studied how to balance the redox reactions by using oxidation number method. Now like oxidation number method, even ion electron method also have certain steps. Now let us see what are these set of rules which are applied for balancing the redox reaction by ion electron method. So first step in this ion electron method is we have to find the oxidation number for individual atoms. Fine. Second one, find out the atoms which undergo oxidation reduction. So these two steps is similar to that of the steps involved in the oxidation number method. So first step we have to find the oxidation number for all the individual atoms present in the compounds, that is the reactants and the products. Second is that in this reactant and product which atom undergo oxidation reduction, so that we have to find out. That is your second step. Now in the third step we have to write the ionic form of the equation. Ionic form of the redox reaction we have to write. Fourth step, we have to separate that equation into two halves, that is oxidation half reaction and reduction half reaction. So that is your fourth step. Now in the fifth step, we have to balance all the atoms except hydrogen and oxygen. Then in your sixth step, we have to balance the charges on both the side of the half reaction equation. Okay, so two half reactions are there. So in that both the sides, both left hand side and right hand side, the charges should be balanced. That is your sixth step. Now in the seventh step, we have to equate both half reactions, yes, such that number of electrons should be equal on both the sides. So both the oxidation half reaction, reduction half reaction, we have to just equate and find the, and we should see that number of electrons on both the sides of this half reaction should be equal. Yes. Now coming to the eighth step, final step, you have to add both half reactions. After adding both half reaction, you have to cancel equal number of electrons on both the sides. So after cancelling the equal number of electrons on both the sides, we get a balanced redox reaction equation. Yes. So likewise, these set of 8 rules are applied for balancing a redox reaction ion electron method. Fine. So now let us take the example of a particular redox reaction equation and try to balance it by using these set of rules. Okay. Now let us see a redox reaction and balance using ion electron method. So KMnO4 plus SnCl2, Sn is your tin, SnCl2 plus HCl gives MnCl2 plus SnCl4 plus H2O plus KCl. So this is your redox reaction. The initial step of this electron method of balancing is, first we have to find the oxidation number for individual atom present in all these reactants as well as the product. Here potassium permanganate. So here oxidation number for oxygen is -2. Yes. So here 4 oxygen atom is there. So 4 into -2, so that gives you -8. Now these two elements in this compound should have the oxidation state +8. Because +8 -8 is 0. So this molecule, potassium permanganate, this molecule is a neutral molecule. It does not have any charge. Okay, now this is +8. That means potassium and manganese together is +8. Now we have to find the oxidation number for potassium is +1. So that we have already studied. Then for manganese how much it will be? It will be +7. So +7 +1. So it gives you +8. +8 -8 becomes 0. So this molecule charge is 0, that is neutral. Fine. So this is a compound. a complex compound with potassium, manganese and oxygen. Now in this case, SnCl2, tin chloride, here tin and chlorine, a diatomic molecule it is. So molecule which is having same element, the oxidation number will be always -1. Okay. Now for tin also we have to find the oxidation number. So what we should do here, I will tell you a simple method to find the oxidation number. So in this molecule, we just divide the first half into plus and second half to minus. Okay, let us give the charge for these atoms in this molecule. So this is not, this compound is simple compared to that was the potassium permanganate. Simple, only 2 elements are here. Okay, so this compound is simple compound it is. Whereas here it is a bit complex because 3 elements are here. So in order to find the oxidation state in a simple way, what I will do, I will give for the first element in this compound as plus sign and the second element I give as minus sign. Okay, yes. Now this is, so chlorine atom, how many atoms are there? 2. So I just put here 2 plus. Okay, then tin, how many atom? Only 1. So I just put here. That's it. So oxidation number for tin is +2 and for chlorine it is -1. Okay, so this 2 can be written here also or here, whatever it is not going to be wrong there. Okay, now HCl also likewise. For chlorine I just give minus sign and for H it is plus. Okay, so it is plus means +1 it is. So 1 atom of chlorine, so I give here 1 and 1 atom of hydrogen, so I give here -1. Okay, so for chlorine oxidation number is -1 and for hydrogen it is +1. Fine. Now let us look into MnCl2. So here also, so here I'll give first for chlorine minus sign and for manganese I give plus sign. Okay, now here 2 chlorine atom is there, so this 2 I just put it here. And here only 1 manganese atom is here, so I just give here. Okay, so chlorine oxidation number is -1 and for manganese it is +2. Now let us look into SnCl4. So here Cl again I give minus, for Sn I give plus. Now here it is 4, so this 4 I write it over here, +4, and here it is 1, or there is no number but we will write it as 1. So only 1 Sn atom or 1 tin atom in this compound, so it is 1, we give minus. So oxidation number of chlorine is -1. Okay, likewise in the case of water also, similarly for oxygen I give minus, for hydrogen I give plus. So for hydrogen H2, it's a molecule, so +2. This 2 is here, yes. So 2 atoms, 2 hydrogen atom is here, so this 2 I'll write it here over 2. Okay. Now for potassium chloride K is KCl, so this also I give minus, here also I give plus. So for K generally we know, we have already seen that oxidation number of potassium is always +1. So here only 1 atom of chlorine, so I give here plus, and 1 atom of potassium give. So now in a simple means, we just found the oxidation number for all the atoms in this redox equation or reaction. Okay, now you can see here chlorine Cl minus and potassium K +1. Fine. Now, so the first step, we have found the oxidation number for individual atoms. Second step is that we have to find out which atom in this equation is undergoing oxidation reduction reaction. Okay, so for that what we have to do, we have to check out the increase in oxidation number. So when oxidation number increase, it is oxidation reaction, right? Now when oxidation number decrease, it is reduction reaction. It is reduction. So this we have already studied. Fine. So this we will just apply it over here. So here for potassium it is K plus 1, whereas on the right hand side also it is K plus 1. No change in that. For manganese, you can see here it is +7, whereas on the right hand side it is +2. So there is a change in the oxidation number, right? Oxidation number from +7, it is decreased to +2. Understanding? Yes. So for that, it is decreasing by 5. So here it is reduction reaction take place. Manganese with the +7 oxidation state, it is getting reduced to manganese of +2 oxidation state. Okay. Now oxygen. So oxygen we know, 1 oxygen atom oxidation number is -2. For 4 atom it is -8. Just for 1 oxygen atom it is -2. So likewise on the right hand side also for oxygen atom it is -2. And Sn it is +2. Yes, whereas here on the right hand side it is +4. So here the oxidation number is increasing from +2 to +4. Yes, of course. So tin is getting oxidized here. Yes, so SN2 plus is getting oxidized to SN plus 4 oxidation state. Okay, so remaining hydrogen with H plus, here also it is H plus 1 and Cl minus 1, so also Cl1. So that is all balanced, all the charges are the same, but only in the case of manganese and tin, there is a change in the oxidation state. Remaining all atoms are having the same oxidation state both on the left hand side as well as on the right hand side. Okay, so in our second step we just found which atom is undergoing oxidation and reduction. So manganese is undergoing reduction reaction, and so written the equation once again. Now we have to write the ionic form of the equation. So which atom is undergoing oxidation, which atom is reduction reaction. So all that we have understood, we have found it out in the previous step. Now in this step we are just writing the ionic form of the redox reaction equation. Okay, then now this potassium permanganate, in order to make it ionic form, I am just splitting it. So iron will be having a positive charge as well as a negative charge. Fine. So potassium, it is always positive charge, whereas MnO4, this having a negative charge. Okay. Likewise, this molecule also, tin is having a positive charge, chlorine is having a negative charge. Okay. Then HCl also like this, positive, negative. Yes, and here manganese too, a positive, a negative. Here also positive, negative. Even here positive, negative. Even here too positive, negative. Okay, now we have split. We are making an ionic form of this equation. Okay, so now which atom is undergoing oxidation? So all and reduction, only that ions we just write it over here. Okay, so here in this potassium there is no change in the oxidation state, right? Manganese there is change in oxidation state. Fine. So I just write this manganese. So MnO4. Write it. Okay. Then here even Sn. In this case Sn is also having a change in oxidation number. Yes. Sn from +2 it is getting changed into +4. So of course the ions or the atoms which undergo oxidation reduction, only that only we should write in the ionic equations. Okay, yes. So here in this case I just write Sn plus, because Sn tin is undergoing oxidation here, and in this case manganese is undergoing reduction. Okay, then here in this case I write positive ion again, H plus. Okay, that gives, now here also I write the positive ion, so manganese, because manganese is getting from +7 is getting reduced to +2. Okay, so I write the oxidation state also along with that. So for tin it is +2, so manganese it is +7, for oxygen it is -2. Okay, then here plus, even here also positive ion, so Sn it is +4. Okay, plus I write H2O as it is. Okay, and then here K plus Cl and Cl minus, this we need not write because these atoms does not have any, because this side we have this K plus I have not written this side, so this side also is not necessary to write. Okay, even Cl I did not write here, so on the right hand side also you need not write, so you just avoid this K Cl, you just avoid, only this many ions you just write. Okay. Yes, so now in this equation, now this is the ionic form of this equation, because in this equation the ions are undergoing oxidation reduction. Yes, so that ions only we will write it here, others we need not write. Okay, so our third step is also over. Fine. So now we are going to separate this equation into two halves. One is oxidation half, another one is the reduction half. Fine. Yes. Now let us write the oxidation half and reduction half reaction. Now this is the ionic equation of this redox reaction. Okay, so from that we just write which is oxidation half and reduction half reaction. So we know which ion is undergoing oxidation, or which atom is undergoing oxidation and which atom is undergoing reduction, so that we know very well. So here this is first one is oxidation half. So here Sn plus 2 is getting oxidized to Sn plus 4. Oxidation means what? Increase in the oxidation number, right? So Sn from +2 oxidation state is getting increased to Sn plus 4. So that I will write it in the oxidation half. So Sn plus 2 get oxidized into Sn plus 4. Okay, now likewise reduction half also we will write. Now what is getting reduced here? Manganese oxide, right? So in this manganese oxide, manganese is getting reduced. Why? Because from plus 7 oxidation state it is getting, oxidation number is reduced to plus 2. Okay, so let me write that. So here I don't write only manganese, I write this manganese ion, MnO4 ion altogether I write. Okay, so MnO4, so the charge of this ion is minus. Okay, so this we have written, we know this charge is minus, so that I just write here. Yes, then plus. So this H plus I write here. Yes, gives, that is Mn plus 2. Mn plus 2. I write it. Okay, then here it is H2O. So that too I write here. Yes, so now we have written the oxidation half and the reduction half. Now after writing the oxidation half and reduction half reaction, what we have to do? The next step is that balancing all the atoms. Yes, leaving oxygen and hydrogen, we have to balance all the atoms now. Okay, yes, now let us look at the oxidation half here. Here tin is having the plus 2 oxidation state here. Here it is plus 4. That means from both the sides the charge should be equal. It should be balanced. Both the sides the charge should be balanced. So here it is plus 4. So it is plus 2. In order to make it balance it, I just add here 2 electrons. Yes, 2 electrons. So electron, we know the charge is minus. So plus 4 minus 2. So 2 electrons, for 1 electron charge is minus. So 2 electrons is 2 minus. So plus 4 minus 2 is what? Plus 2. So now here the charge is balanced here. Okay. Yes. Now let us balance the atoms in the reduction half. So here manganese oxide. So this ion, here it is the charge is minus. And here H for hydrogen plus. And here manganese charge is plus 2. And here hydrogen, 2 hydrogen atom is there. Whereas here only 1. Fine. Oxygen, you see here it is only 1, whereas here 4. So to balance that oxygen, what we are do? I just put here 4. Yes, I put here 4. Okay, now it is 4. 4 hydrogen atom is there and 4 oxygen atom. Now oxygen is balanced both the side. Whereas hydrogen it is 8. So what will I do? I just put here 8. So 8 H plus ions are there now. Okay, so hydrogen is also balanced, oxygen is also balanced here. Fine. Now we have balanced the charge. Fine. So here minus 1 charge and here 8 plus charge. Okay, so here minus 1 plus 8. So how many? It becomes plus 7. So here the charge is plus 7, whereas here the charge is plus 2. Okay, so here plus 2 and here it is plus 7. So we should equate the charge on both the sides. No. So for that reason what will I do? I will just add here 5 electrons. So when I add here 5 electrons, it becomes minus 5. So plus 7 minus 5, how much it is? Plus 2. Now this side also plus 2, this side also plus 2, it is balanced. Okay, now charge is balanced. Now after that what should we do? We should equate both half reaction. Okay, so while equating both half reaction, what happens? The number of electrons on both the sides should be equal. Fine. In order to make the number of electrons on both the sides, that is both oxidation half reaction as well as reduction half reaction, the number of electrons should be same. Okay, but at present here 2 electrons are there, whereas in the reduction half there is 5 electrons. So number of electrons on both the sides are not equal. So in order to make it equal, what should we do? This oxidation half reaction, you are multiplying with this 5. Okay, so you are multiplying into 5. Okay, likewise the reduction half reaction, you are multiplying with this 2. So that is into 2. Got it? Fine. Now let us multiply with 5. So here only one is Sn plus 2 ion. So I just multiply with 5. So 5. Similarly here also 1. So I just multiply with 5. So 5. 5 Sn plus 4. So here 2 electrons are there. So when I multiply with 5, it becomes 10 electron. Okay. Now likewise here we are multiplying with the 2. So here there is only 1. So 1 into 2, 2. So 2 MnO4 minus ion plus 8 H plus ions are there. So when you multiply with the 2, it becomes 8 2s are 16 H plus ion. And here 5 electrons are there. So 5 electron into 2, so 10 electron. Yes. Now here only 1 Mn2 plus ion. So I multiply with the 2, so it becomes 2 Mn plus 2 ion plus H2O is there. So when I multiply with the 2, it becomes 8. Okay. Yes. Now in the next step, what should we do? We should just add. Now we have equated both the reactions. The number of electrons are equal in both the. So here it is 10 electron, or is there also 10 electrons. So number of electron on both the oxidation half reaction as well as reduction half reaction, it is equal. Okay. Now the next is we have to add both the oxidation half reaction as well as reduction half reaction. Okay. Now I have written both the reaction. So the biggest reduction half, this is the biggest reaction here, so that I have written first, and below that I have written the oxidation half reaction. So both reactions we are just adding. Okay, so while adding, what happens? 10 electron and here 10 electron, it's cancelled. Yes, we are cancelling equal number of electron on both the sides. Okay, fine. So now what will I do? I'll just write, after cancelling, I'll just write 2 MnO4 minus plus 16H plus 5 Sn plus 2 gives 2 Mn plus 2 plus 8 water molecules plus 5 Sn plus 4. Okay, so now this reaction is balanced. Now let me rearrange this balanced equation. Yes, so first I write 2 MnO4 minus ion plus, then I write 5 Sn, tin ion I write 5 Sn plus 2, then I write 16 H plus ion gives 2 Mn plus 2 plus, I write 5 tin first. Okay, so 5 Sn plus 4 ion, tin ion plus 8 water molecule. Fine. So this is the balanced redox reaction. So now we can check it out. 2 manganese ion is here. Even here also 2 manganese ion. Here 5 tin ion is there. Even here also 5 tin ion. Here 16 hydrogen ion is there. Here also 16 hydrogen ion is there. Yes. Here 8 oxygen atom is there. Here also 8 oxygen atom is there. So now the redox reaction is completely balanced. Fine. So hope you understood this method of balancing. Thank you.